Welcome to today's deep dive. Imagine you are trying to film a live stadium broadcast, right?
Right.
But you're stuck smack in the middle of a blinding blizzard or, I don't know, maybe a massive rock concert, and the torrential rain is just absolute chaos.
Oh, man, yeah. I mean, those are the exact conditions where standard electronic equipment, well, especially highly sensitive broadcast gear, usually just gives out completely. Like motors freeze up or lenses just fog over entirely.
Exactly. But today, we are looking at the tech that refuses to die. Our mission for this deep dive is unpacking the specs of the Bolin Technology EX1030NX Outdoor PTZ camera.
Yeah, that is a beast of a camera.
Right. I mean, it is a $7,995 piece of hardware, and we really want to figure out how broadcast professionals use it to capture just flawless footage in those extreme environments.
Because it's definitely not your standard gear.
No, not at all. Looking at the sources, it's got this IP67 corrosion-resistant housing, and it handles temperatures from like -40 degrees Celsius all the way up to +60 degrees.
Which is insane. I mean, live broadcasting is basically an ongoing war against physics.
Yeah, it really sounds more like military-grade survival gear than standard TV equipment.
It is basically an armored box. But building something that survives a blizzard is really only half the battle here. The real trick is engineering a system that can actually see anything useful while taking that kind of a beating.
Right, because surviving the storm is great, but if your shot is, shaking wildly or it's too dark, the broadcast is dead anyway. So how does it physically pull a usable shot in those conditions?
Well, it really comes down to the optics acting almost like a highly sensitive digital retina. So inside that shell, there's a Sony 12.8-inch Starvis 2 sensor, and it's paired with a 30x optical zoom.
Okay, wow. 30 times.
Yeah, it's massive. And that Starvis 2 is specifically engineered to pull color and fine detail out of near total darkness. But honestly, the mechanism keeping it steady is the crazy part. They use the ZDP technology, which stands for zero deviation positioning.
Wait, I want to focus on that stabilization for a second, because if you're zoomed in 30 times, I mean, even just the bass from a stadium concert is going to rattle the lens, right? Is ZDP just absorbing that shock somehow?
No, it's actually much more active than that. So ZDP uses these highly calibrated stepper motors and internal feedback loops.
Okay, got it.
So if that stadium bass knocks the lens even a single millimeter off target, the camera instantly calculates that deviation, and then it micro-corrects the motors in real time to counter the movement.
So it's kind of like a surgeon using a Steadicam rig during a minor earthquake or something? Like the external shell is vibrating, but the internal mechanics are actively moving in the exact opposite direction, so the lens stays dead still.
That is a perfect analogy, yeah.
Which makes sense. But the sources also mentioned this integrated long-range laser working with that lens. And I gotta ask, if I'm half a kilometer away in a pitch-black stadium, a zoom-synchronized laser seems like it would just blind the live audience.
Well, it absolutely would if it were standard light. But this is an infrared laser.
Oh, I see.
Yeah, so it tracks mechanically with that 30x zoom to project this really uniform infrared illumination exactly where the lens is looking. So it keeps the scene bright for the camera's sensor, but it remains completely invisible to the crowd.
Okay, so the sensor and the active stabilization basically guarantees a crisp, well-lit shot. But a massive, uncompressed video file from a 30x zoom lens is, incredibly heavy data.
Oh, absolutely massive.
So how is that data surviving the trip from the freezing roof of the stadium all the way down to the broadcast truck instantly?
Right, so this is where it sort of shift from the eyes to the brains of the unit. The camera has dual video outputs. There is 3G SDI for the traditional uncompressed live video feed, which has almost zero latency.
Right, the standard broadcast stuff.
Exactly. But then there's also NDI HX3, which compresses and sends high-quality video really efficiently over standard internet networks. And to streamline the whole physical setup, it uses PoE++ seed or power over Ethernet.
Wait, so just one cable for everything?
Yeah, exactly. One single heavy-duty cable handles the raw power, the high-res video, and the IP control command simultaneously.
That is super efficient. But I did see Freed protocol for AR and VR in the spec sheet, which honestly felt totally out of place for an outdoor camera.
It does sound a bit weird at first, yeah.
Because usually to do augmented reality, like, that glowing yellow first down line in American football, you need a whole separate rig of motion tracking sensors around a stadium. So is this camera doing that internally?
It is, yeah. Freed is basically a protocol that allows the camera to constantly stream its exact positional data.
Like where it's pointing?
Right, so its pan, tilt, zoom, and focus metrics go directly to the broadcast truck's graphics engine. So instead of relying on external stadium trackers to know what the camera's looking at, the camera just tells the computer exactly where it's aimed in equal space.
Oh, wow. So that drastically simplifies the process of overlaying those virtual graphics perfectly onto live panning outdoor footage.
Exactly. It essentially acts as a localized, invisible bridge between the harsh physical reality of the event and the polished digital broadcast we end up seeing at home.
That is incredible. So the next time you watch a flawless outdoor live event and you see a virtual graphic tracked perfectly across the field during a sweeping camera shot, well, you will know the exact self-correcting armored data center doing the heavy lifting behind the scenes.
It's pretty wild to think about.
It really is. Which leaves you with this final thought. If cameras like the EX1030NX can seamlessly blend physical reality with AR and VR on the fly, calculating micro movements in real time, how long until watching a live sports broadcast feels entirely like navigating an interactive video game where you control the overlays? Something to ponder until next time.